Yes, so, test, well. And my slides are up as well. All right, so thank you all for coming here, and I'm like really happy to be here and present in real life, right? It's so much better than presenting in front of my computer and a screen. So my name is Rinke, I'm the product owner of Swarm, and well, I'm here today to talk about Swarm, surprise. But before I start, let me ask you, who heard about Swarm before? All right, that's good. And who ever heard a very simple explanation about Swarm? One guy, two. Okay, that's good. So I didn't make my presentation for nothing, because that's exactly what I'm going to do right now, to present a simple and concise and accurate mental model of Swarm, which will help you to explore and understand the benefits of using this tech for yourself. So let me get started with presenting what Swarm is. And for myself, I actually mostly like to conceptualize Swarm as this global hard drive, which is hosted and operated by computers which are running all across the world and which collaborate because they have the financial motivation to do so. And just as with a normal hard drive, in the Swarm hard drive, you can also upload and download, right, and store data. So in Swarm, you can also upload, and basically when you upload content to Swarm, which can be a file or a website or something like that, this content is split into many small pieces. We call them chunks. And these chunks are literally spread all across the globe, right? And then downloading basically constitutes requesting this chunk by whomever wants to request a file, and puzzle it back together. And here it's important to take notice of the fact that actually in Swarm the nodes don't store files, they don't store the website, but they store these chunks which are part of a bigger context. So only for the person who is downloading this content, actually the chunks make sense. And being this global hard drive, there are a few very interesting properties of Swarm. And the first thing is that Swarm has privacy-preserving and permissionless upload and download. Swarm has robust defenses against blocking or changing access to content once it is published. Swarm auto-scales with an increase of demand. The content is integrity protected. And Swarm also eventually forgets the content that is no longer relevant to preserve. All right, so now you know what a Swarm is. And of course, you're asking yourself, okay, so how does Swarm work? How do you get that? I'll be talking about that next. I'll be touching up on the network, then about upload and download, about how Swarm deals with finite capacity, and then in the end, I'll briefly touch upon how Swarm fits in the Web3 stack. So how does Swarm work? Well, the first thing that is important to notice is that Swarm is not your regular piece of software. Well, maybe here at EFCC it is, because here we're talking all about decentralization and blockchain and decentralized protocols. But if I'm talking to normal software developers and I'm explaining them what Swarm is, like it blows their minds, because Swarm doesn't run just on one computer, but actually it's a collaboration of nodes who share and talk the same protocols and they collaborate together. So I put here a picture of a bee and a picture of a swarm, and that's because, well, Swarm is the eventual network and the product that you're using, but actually bee is the software that the individual computers run. And a user is motivated to run bee for two reasons. First of all, by running the bee software, you have access to the Swarm network, so you can upload and download. And also, if you have the computer laying around or a Dapps node or something like that, and you run on it the Swarm protocol, you're actually earning a bit of money from your spare bandwidth and hard drive capacity. All right, so the second most important thing to know about Swarm is Swarm's network. And for those people familiar here with the technical term, Swarm uses a specific flavor of Kademlia called forwarding Kademlia. And for those who don't know what I'm saying, I'm just going to explain it now, so don't worry. All right, so I'm having here a very nice little small Swarm network with 16 nodes. In real life, of course, Swarm is most likely going to be much larger than 16 nodes. In fact, right now we're having a network running with 200,000 nodes all around the world. But I'm just taking this 16-node network because it's easy to explain. All right, so you see here Alice and Dave. And these two nodes, I just gave them a name. And Alice and Dave both have an address. Alice has an address starting with all zeros, and Dave has an address starting with all ones. And let's say that we want to send a message from Alice to Dave, or to any other node for that matter, but we're going to send it to Dave. And the question now is, what kind of connectivity pattern does Alice need to follow in order to always be able to send a message to Dave? With 16 nodes, you can imagine, okay, well, Alice just connects to all the nodes. But if you imagine a network of 200,000 nodes or even more, you can imagine that it's just impossible to connect to all the nodes. So they need to choose their connections carefully. So the first thing that Alice does is to bring some order into the network. And she splits the network basically in half. One half of the network is reserved for all the nodes that start with a 0. And the other half of the network is reserved for all the nodes that start with a 1, like Dave. And she makes one connection in that part of the network with a different first bit. So we call that bin 0. All right, but we're not yet there. We need a bit more order in the network. So what Alice does, she divides her part of the network again in two. Now splitting up those nodes with a different second bit and those nodes with the same second bit as Alice. And also make one connection there in bin 1. Yeah? And the last order which Alice applies is, well, split up her quarter of the network again. Those nodes with a different third bit we call bin 2, and we make one connection. And then everything which is left we call the nearest neighborhood, which are basically the nodes who are having a very similar address to Alice. And we connect to all the nodes in the nearest neighborhood. In the real Swarm network, this basically looks like right now we're having 12 bins, but this number varies, right? The nodes, they come and go. So it can go up or down, and we don't make just one connection in each bin, we make a couple of them to ensure that we can just always operate even though there's continuous flow of nodes coming and going. All right, so this is how Alice orders a network and how Alice decides what connections to take. But what about the original example of Alice wanting to send a message to Dave, right? That's how we started. And as you have seen, Alice is connected to Bob, but Bob is not the same as Dave. So how can Alice send a message to to Dave? Well, what I'm claiming is that if Bob follows exactly the same logic with the bins and with making the one connection, then basically we don't guarantee that Bob is directly connected to Dave, but we can guarantee that Bob is at least be able to forward a message to a node that has a more similar address to Dave than Bob has, right? So this is how it works. And by the way, I highly invite you just to plot this thing for yourself and to think about it, and you're able to validate what I just said. But for now, we're just Alice, and Alice wants to send the message to Dave, but Alice doesn't know how to reach Dave, as we've just seen. She's not connected to Dave. But Alice is connected to Bob. So she sends a message to Bob because she knows that Bob's address is a bit more similar to Dave than herself. She says to Bob, "Hey Bob, I'm having a message for Dave." And Bob is like, okay, I don't know Dave, but I know Carol, and Carol is more likely to know Dave. So Bob sends a message to Carol, says, Carol, hey, I'm having a message for Dave. And Carol's like, okay, I know Dave. Right? So sends a message to Dave. And this is how Alice can send a message to Dave, but also to any other node in her network. And of course, swarm nodes don't just pass messages, right? So a swarm is a protocol for decentralized storage of data. So swarm nodes store chunks, and the message passing is for upload and download. And remember again, these chunks, I spoke about it before. These are these very small pieces of data that belong to a file or belong to a bigger piece of content. And those chunks, they, well, don't look like that, but I can represent it like this. They contain data, and they have an address. And this address is very important because it's basically this address that defines what nodes are going to store the chunks. So a chunk that has an address that starts with all ones will be stored by those nodes that have an address similar to that. Just as we could compare the similarity of two addresses, we can also compare the similarity of an address of a chunk and an address of a node. So that's how we can define that a chunk is stored by, well, in this case, Dave and the neighbor of Dave. Just as Alice had this nearest neighborhood, Dave also has a nearest neighborhood, and that's why we can define that they both store this chunk. So the chunk is stored by always more than one node, again, to facilitate that the chunk stays in the network, even if nodes come and go. And the address of the chunk is actually defined as the hash of the data, or it is attested by a digital signature of the uploader, so that provides integrity over the data. All right, so now we have the two most important components actually to define upload and download in Swarm. Because we know that we can pass a message to any other node in the neighborhood, and we also know that those nodes store a chunk if their address is very similar to that chunk. So we can just define upload and download as follows. Upload is basically to route a message to the neighborhood of the chunk, and that message basically is the chunk, so it's a chunk data. And it's answered by a receipt confirming the storage of the data. Download basically is to request to send a message to the neighborhood, chunk request message, which then is answered by the chunk. So I'm having here again our four friends, Alice, Bob, Carol, and Dave. And you see here that Dave is storing a chunk with the address of 4 ones, right? So Alice wants to request that chunk. And what she does, she sends a message to Dave. In this case, it's a chunk request message, passing via Bob, via Carol, via Dave. And Dave is like, OK, I'm having this chunk, so let me pass it back to Carol, to Bob. And Bob eventually passes it to Dave, to Alice. And Alice uses this chunk together with all the other chunks that she is requesting to, I don't know, create a file, maybe the Cypherpunk manifesto. All right, so she has the chunk. And it's important to realize at this point that nobody knows who was the originator of a request, right? So you can imagine this forward chain. Dave knows that the chunk was requested by Carol, but doesn't know whether Carol was the originator of the request or just a forwarder. Carol has the same about Bob. Carol doesn't know whether Bob was a forwarder or the originator. And so also Bob only knows that Alice requested this particular chunk from him, but she doesn't know whether Alice actually was downloading this chunk for her own consumption or whether she was just, I don't know, sending it to somebody else. Right? So this facilitates the privacy of whomever is downloading via Swarm. And you might question yourself right now, okay, so actually why do these nodes help each other in passing of these messages? And that's because the nodes are actually financially motivated to do so. So I'm having here a little table, and you see, again, Alice, Bob, Carol, and Dave. And just as we can compute the similarity between two addresses, We can also compare the distance, which is basically the inverse of that. So Alice has a destination of 4 to the chunk of 4 zeros. Bob is a bit closer, Carol is even closer, and just Dave has infinite similarity. So based on this distance metric, we can define how much people are going to pay. So Alice is furthest away, so she pays 4 to receive this particular chunk. And she pays it to Bob. And Bob on his turn is also requesting this chunk from Carol, so Bob pays 3, pocketing a profit of 1, right? Same for Carol and for Dave, and you see that everybody in this whole chain is receiving a bit of profit from actually honoring the request of Alice. So this profit can be either in the token of Swarm, BZZ, or it is paid in a reciprocal service or just by waiting. So it is possible to use the Swarm for free. For example, you just want to send a download link to a friend, and the friend can download it, so it just doesn't need to pay BZZ. But if you're, I don't know, streaming a movie or a live stream or whatever, you will need to pay a bit of money to basically incentivize the network to help you in routing all these chunks from all across the network. Okay, so I was going to explain how Swarm works, and right now we know how the network is being built up. We know how upload and download works. The only thing that I'm going to talk about right now is how Swarm deals with finite capacity. So again, picture yourself this, global hard drive, and think about a normal hard drive, right? Eventually it fills up, right? If you just put a lot of movies on your hard drive, my hard drive is full, and what I'm doing myself, I'm buying a new hard drive, or I just delete some movies which are not relevant anymore. But before I said that in Swarm, content once published cannot be changed anymore, and also nobody can revoke access from anybody. So basically it's in the public domain. So Swarm has no deletion operation. So how does Swarm then deal with finite capacity? And basically how we do that is every chunk in Swarm has a reference to an on-chain payment, which signals the value of that particular chunk. So this on-chain payment, together with some expected profit measure from the nodes, who are like getting profit from serving it, allows the nodes basically to order the chunks based on their value. And this is how in Swarm always the most relevant chunks are preserved. And those chunks which don't have such a payment, or which are not requested anymore, are eventually replaced by more relevant content. So Swarm always preserves the content that is most relevant to preserve at that moment. Okay, so I explained what is Swarm, and what is left basically is to talk about how Swarm fits in the Web3 stack. And as we say in the Swarm white paper, Swarm caters for a sovereign, self-sovereign global society, freedom of expression on the web, and a permissionless open markets. But up until now, I've been only talking about chunks and small pieces of data. It's not really something that, I don't know, Edward Snowden can use. So you see here these layers, and what I've been talking about right now is the disk. So it's the distributed, immutable store of chunks. This is really the pure hard drive, and just as a hard drive on its own doesn't really give meaning to the data, the disk also doesn't give meaning to the chunks. It's basically the data structures and how you interpret those chunks that give meaning to those. So that's already possible with Swarm, with the B node. You can request files, you can request directories, you can define dynamic content, you can send messages in a private and permissionless manner. And together, all these puzzle pieces, they form the fundament to actually build decentralized applications on top of Swarm. And these decentralized applications can really be anything, because Swarm, it's this global hard drive, but you can also visualize it as basically a serverless server which is hosted by so many nodes, and you can visualize it as a Dropbox, really the sky is the limit what we can build on top of Swarm, and also Swarm is built in such a way that it's really this layer in the stack. So it's, we really try to make it easy for developers to build whatever they want on top of Swarm. So that's why we're here today also with Swarm, and I'm not the only one, you'll find more people. And we're really happy to talk to you about how you could use Swarm in your product. We really believe that that Swarm and blockchain and all these things, they're going to change the world. And yeah, so with that, I would like to invite you to try out Swarm 1.0 today. I have a couple of links here. You can scan the QR code to get a link to this presentation. And yeah, thank you to La Fay. That was it.
Questions from the public? Raise your hand. One there. Just a second.
Yeah, my question is, what's the latency when you insert data and when you want to retrieve? I'm thinking like, is it possible to make some games where you record the position of players, this kind of stuff?
Yeah, right, so that's a good question, so thanks for asking that. So the latency, imagine yourself a computer from the 90s. Well, maybe that's around the latency. So Swarm, you can imagine orchestrating, downloading these chunks all around the network. It's like quite a complicated puzzle. We have the Swarm 1.0 out there. You can use it. You can put your content on it, which then can't be deleted anymore. But for the time being, it's really not so fast, right? So we're working on it with a very good team of developers and a whole organization that is, we're making it better and better, and releasing software regularly. So we hope to make it fast. Maybe in a year from now or half a year, you can download games and put it as a backend for that. But for now, I would advise you maybe to sign up for our newsletter, and you'll be able to follow our process. And yeah, keep an eye on us. And for sure, we want to cater for you also in the future.
Question?
So I have two questions. So one, how do you compare it to Filecoin, especially with regards to tokenomics and
Sorry, where are you sitting?
Here.
Yeah.
And the second one, in the past you had service for messaging, like a queuing messaging. Yeah, so is it integrated, or what's your plan with that?
I'm having a hard time understanding what you say. Can you repeat maybe one question?
Right. So the first one was, how do you compare it to the Filecoin?
How do I file?
Filecoin, how do you compare it to the Filecoin?
How I am comparing to Filecoin. Okay, so I find the most prominent difference with Filecoin that actually in Filecoin you're not uploading content to the network. Basically what you're doing in Filecoin, and basically this is IPFS, right? So Filecoin is the incentive layer on top of IPFS, but in IPFS we are announcing to the network that I am storing a particular file. And in Swarm, you really upload that file to the network. And you're not just uploading the file to the network, you're uploading the chunks containing that file to the network. So that's really important if we're talking about permissionless upload and download, and also to protect the privacy of people, because in in IPFS, you're always storing the content, and if that content is content that people might not want you to store, basically you're always liable for the content that you're storing yourself. And in Swarm, there's no such liability, because nodes don't store files, they store chunks, and it's impossible for, no, I wouldn't say impossible, but it's really hard to make a node liable for the content, for the chunks it's storing, because there's plausible deniability, right? So a node stores a chunk, but the node doesn't know what file this particular chunk is part of. So that's I think the most important difference between Swarm and IPFS.
Hey. I have a couple of questions. Two is very simple. What is your network capacity estimate right now, and what is the number of active nodes in the network?
Right, so the network capacity, as I already said, we have 200,000 nodes at the moment. The standard database size of Swarm, I think it's 30 gigabytes, so do the math. That's your network capacity at the moment. But the more people use Swarm, the more expensive it costs, the more profit node operators get. So we also expect this capacity of the network is basically dynamic, where it comes and goes with the usage of the network and the profit that node operators can make by running Swarm.
Are those 200,000 all active?
Sorry?
Those 200,000 nodes all active?
They're all active.
Wow.
Yeah.
Cool. And another question, is it S3 compatible, Swarm, or?
Can you repeat it, please?
Does Swarm S3 compatible?
If Swarm is Turing compatible?
No, not Turing. S3, AWS S3.
No, at the moment it isn't. But as I already said, we are providing the low-level access into Swarm. So yeah, is a hard drive Turing compatible? Well, a hard drive probably not, but the programs running on top of the hard drives are, and Swarm is exposing both the higher level and the lower level APIs. So, any developer here wishing to make Swarm S3 compatible, we would love to talk to you. And I think we also have grants for that. Oh. All right, I think that's it. Yeah, thank you.